Hello, I'm Justin for CG Tuts Plus, and today we're going to create some shattering effects with text in Maya. So we can just have a look at a couple of examples here of what you can do. You can see it's shattering on the ground there, and here we have the plus coming up, shattering that, and for this one I just kind of shattering it out like that. So let's have a look and see how we can do this in Maya. Okay, so now that we're in Maya, let's first try and create a text object. Let's see. And as you can see, you can write whatever you feel like here. I like CG Tuts Plus, so I'll stick with that. Let's first see how this works. Try the curves, and as you see, it will create a curve outline for you. The trim tool will hit 3 to get it smoothed. The trim tool will make trimmed versions for you, but as you can see, it's not that accurate. So let's get that away. The polygon will create a polygon plane out of the thing, but as you can see, the accuracy is all over the place, so we can't do that. The bevel tool works so that it actually takes the text and it bevels it out, and as you can see, it gives a really nice result. But there are some problems involved. Let's see how we can work with this. First of all, I'm going to separate them so that each letter is a different mesh. Now have a look at the outliner. You can see the group here, different mesh, and let's see how the shadow effect works on this one. If we try the C, let's see, then go into the dynamics menu, effects, and then shatter. So you have surface shatter, solid shatter, and crack shatter. Let's have a look at the solid shatter first. What it does is it takes the whole mesh and just creates these different shatters out of it, or shards, I guess it's called. Right now it's set to 4 and jaggedness is 0.3 and so on and so forth. So let's apply that, and you get narrow. And the reason for that is because the shadow does not like history. So let's go in and delete history, and let's try again. And now you can see it's working on it, and there we have a shattered C, and you can see that we have this different parts here. So I'm just gonna shift P that and unparent it from this group. But like if you try, for instance, the T, you get an error and it just gets huge and nothing happens to it. So it isn't exactly that efficient. Now, if we were to pretend that it actually worked on all the letters, let's just delete this so we keep the shattered C. And let's see how this works if we actually, let's just create a plane, and let's try to make this active rigid bodies, because we're gonna have fields working on it, so it has to be an active rigid body. Mass 1, now the bounciness is by default is 0.4. I like to turn it down to 0.2 because I think 0.4 is a bit too much bounce, so apply that. And now all these are rigid bodies, and let's select the plane and make that a passive rigid body because it's not going to be affected by any fields. And then one thing that is very important when you're going to do calculations is to make sure that you have play every frame, playback speed, so that it actually can calculate every frame. Otherwise it will have problems. And then let's turn this up to 100 and play. So as you can see, it is working, but it's very slow, and actually when it reached the, let's see, I'm just gonna help it out a bit by moving this up a bit so that it doesn't have that far to fall. No, let's see. Okay, and now it's calculating the dynamics, but as you can see, it takes forever. At least on my computer, it's not very fast. And another problem with the effect that we used, the solid shatter, is that the parts are very close to each other, and as soon as you have like an intersection between the different parts, Maya has problems calculating the different shards. So let's try another method of doing this. Okay, so I've just gone in and deleted everything here, so we can start again. So let's first create a text tool, and this time let's create the curves. And now we get the curves going here, and let's create a NURBS plane and just rotate it, let's see, 90 degrees on X, and scale it out 5, let's see, just so that it covers the curves, and then move it back a bit. And then I'm going to move to the front view, and if you select the curve and then the plane, you can go into the NURBS menu and select project curve on surface. So once I've done that, just select each of the letters, hit G, and the background G, and this G, and this G, and the S, G, and the plus G. Okay, so now we have projected our curves onto the surface. And what this does is that when you have the history on, you can see that it stays in place, and as soon as you move outside the group, you get an error message because it doesn't really understand what's going on. But and if you move these around, you can see that the projection is actually following. So once you have that, let's just go in and delete the history, and now when you move it, you can see it stays in place, nothing happens. So let's just delete the curves, and to cut out these letters, let's use the trim tool, which is here, and select each part that you actually want to keep. So the T and the U and the T and the S and the plus, and then hit enter. And then you see it looks pretty weird, but if you hit 3, let's see, you can see that it actually it does a really good job with accurately cutting out the different pieces. It looks pretty bad in the viewport, but if you make a quick render here, oops, that's pretty big. Let's see, you can see that it actually cuts it out pretty good. So now what we want to do is take this and convert it into polygon. Alright, so to convert it into polygons, let's select the NURBS plane and go to modify, convert NURBS to polygons. Now I'm going to explain why we're doing this in a bit. It's usually much easier to work with polygons than with NURBS. So let's see, what are the reset settings? These are the default settings. Now I like to do to match the render tessellation. That means that it takes the rendered image and it tries to create a polygon mesh that is as close to that as possible. So if you apply that, you see that you have this mesh that, and let's just make a group for that and hide it. And now you can see that we've got an accurate result rather than what we did with the text tool when it tried to do the same thing. It wasn't accurate at all, but now, as you can see, it's actually, we managed to get this nice mesh, or nice, it's not nice, but it works. So now let's see what we can do with this. Let's first make sure that the normals are the right way, because that I'll just hit shift and right click polygon display and toggle face normals, and as you can see, that looks good. They're all facing the same way. So let's turn that off. That's shift, a right click, polygon display, toggle face normals. And now let's go into our dynamics and let's go into the effects, the shatter. And now instead of using the solid shatter, let's use the surface shatter, because the surface shatter has the same settings, but it has an extrude shards. So what it does is that it cuts the plane and then extrudes the mesh. And now we have extrude to 1. So let's apply, again, that did not work because we have to delete the history. And then try to apply it. So now it's thinking, and now we have all these different bits and pieces, but it didn't do the C. So let's delete that, and let's do the same thing as we did with the texts before. We actually separate the different pieces, so we get each letter by themselves. And again, select them all, edit, delete by type, history. And let's start with a C, apply. So now you see that you have these different pieces and it's been shattering the C. Let's do the same thing with the G and the T, and you see how quick it is, and it actually works on every letter. And now we can actually first, let's just select all the shattered letters and shift P to unparent them and just delete this. So now we have all these different shattered letters, which we can work with and create some dynamics. Okay, so now that we have all our, all our letters here, all shattered up into different pieces, let's go in and play around with this. Let's first create a plane, move it down a bit, and let's select all of our shards and then create active rigid bodies. Now for the plane, again, let's create a passive rigid body. We don't want it to be affected by any of the fields. So again, select all of your shards and I'm just gonna go for a gravity this time, and then make sure it's on play every frame and make sure you have enough frames for it to calculate. Let's go to 50 for now, and then let's see how this works. Okay, so it's falling down, hits the ground, and then shatters. It seems to be working alright. Every now and then you get a bit of unpredictable results because of the calculations that Maya does. You can see that here it sticks together, probably because they're intercepted or stick together. But all in all, it seems to be working pretty good. So let's go in, and if you want Maya to actually to save the calculations in the RAM, go into the solvers, memory caching, and enable. Another way of doing it is if you select one shard, you see here you have this rigid solver attribute, and this is the solver that controls all the solving when it comes to the calculation. So if you go into the rigid solver state, you can see that you have the cache data there. You can turn that on or off. Let's turn it on, and now it will keep the calculations in the RAM. So when it is done calculating, it will automatically play the calculation that it is just done. So let's see how this works. It breaks up. Everything looks pretty good. And let's just hide the outliner. And it's, it's a bit slow, but okay. So now you see that it actually plays it back. And then now you can go in and change to like a more normal speed. And as you can see, you get a bit of like unpredictable results every here and there, but all in all, it works pretty good. So if you want to change something, let's move that down a bit. Now it needs to do the calculations again. So if you go into the rigid solver and then hit delete on the delete cache, now it's going to start over and do the calculations again. And of course you need to go in and change to play every frame and just delete the cache again, and as you can see, it starts over with the calculations. So now we can just play around with different setups to see if we can create some cool effects. Alright, so just to show how you can use this to play around, you can actually, let's just try to create a box, and let's just place it underneath the text that is falling down because it's still affected by the gravity field. And if you make this, let's see, let's make that a passive rigid body too. And Control A moves you to the attribute editor, and then let's go into the rigid solver node, delete the cache, whatever you want to call it, and play it. And now you should see that it actually hits the box and it breaks up some of them, and things are getting chaotic here. So okay, now you can see that works fairly well. Not too many unpredictable results. And what is also possible is, it's pretty cool because you can use all these fields to influence the rigid bodies. So turbulence field, air drag, you can play around with it as much as you want. Or you can take, for instance, this box. It's already a rigid body, so let's use that to just smash it. Let's actually delete the gravity for now, and just when I want to animate the box, there is a problem, because when I move the timeline, the calculation is going to start. So it's going to be if I delete the cache here, so you can see if I drag it, it's very slow and it's trying to calculate the motion of these letters. So to fix that, I'll just go in and say start time, let's say 200, which means now I can move this timeline and nothing will happen. So let's set a keyframe here and let's move it to 30 and let's just blow it in there. Okay, set a keyframe there. As you can see, it doesn't actually create keyframes in the timeline because it is a rigid body. So to see the keyframes, you can go into animation, the graph editor, and then you can see under the rigid body input, you can see that you have the keyframes here. So if you want to change them, you can go in and do it here. It's just the way it works with the rigid bodies. So now we have that. Oh, I'd actually moved it up a bit. I didn't mean to do that. So let's go into the graph editor and oops. Yeah, let's just actually delete the X and the Y so that we can just move it in the Z. Okay. So now we have that, and now it's gonna go through and blow the letters away. So Control A, go into the rigid solver, change this to 1, and make sure that it is play every frame, and play. Oops, maybe we should delete the cache too. And then as it is moving, it's getting closer, and there you can see, smashing it up. And of course, since it doesn't have any gravity now, it'll just move the ones that is affected by the box. But you know, you can play around, do whatever you want with this. If you want to change the position of the letters, I would suggest selecting all of them, creating a group. Control G. Okay, and then you can take the group and move it around. Right now it's struggling. Let's see. Let's rotate it like this. It's gonna actually delete this, and again, rigid solver, delete, and let's play this back. Oh, I was gonna actually select them, and fields, I'm just gonna use gravity again, and again delete plate. Now as it's falling to the ground, it's gonna break up when it hits. You will encounter problems where you get intersections between the different parts and things will just start flying randomly around, but then you just have to change some of the parameters in the simulations, and it should work. But it is not the most predictable simulation program. I guess you can use other programs to create better effects like Houdini, or more specialized programs. But for now, this is a pretty good method that works fairly well. So hopefully you can use this for something useful, and that's it for me for this time. Good luck and have fun.